What if I told you that Neptune's northern lights don't appear in the north? That the glow which should crown the very top and bottom of the planet instead shows up stranded near its middle, in completely the wrong place, as if the world had been knocked off its own rules? For more than 30 years, every other giant planet showed us its lights exactly where we expected them. Neptune refused. And when we finally caught its glow, it wasn't sitting where any law of planets said it should be. That alone would be strange enough. But the reason those lights ended up in the wrong place points to something far bigger. Something that had quietly happened to this entire world while no one was watching it closely enough to notice. The Neptune we thought we knew, a frozen, sleeping, finished thing, turned out to be changing right under our telescopes. And we only found out because the most powerful telescope ever built finally turned to look at the most overlooked planet in the solar system. What the James Webb Space Telescope saw there did not match the picture we had trusted for 35 years. To understand why that was such a shock, you first have to understand how little we have ever actually been able to see of this place. Neptune is the farthest planet from the Sun. It orbits at roughly 30 times the distance between the Earth and the Sun, about 4.5 billion kilometers out into the dark. From that far away, the Sun is no longer a warm disk in the sky. It is just a single brilliant star, and Neptune receives only about 1/1000th of the sunlight that reaches your skin on Earth. It is so distant and so faint that you cannot see it with the naked eye, no matter how dark the night. For almost the whole of human history, we had no idea it was even out there. And the way we finally found it is unlike the discovery of any other planet. Because Neptune is the only planet we found not by looking, but by doing the math. In the 1840s, Uranus was drifting slightly off course, tugged by something unseen farther out. A mathematician named Urbain Le Verrier calculated exactly where that hidden world had to be, and in 1846, astronomers pointed a telescope at that precise spot and found Neptune within the hour. Stop and think about that for a moment. We discovered an entire planet with a pencil and the laws of gravity before anyone had ever laid eyes on it. But that orbit is so vast that Neptune takes about 165 years to circle the Sun even once. A single season there lasts roughly 40 years. A person could be born, grow up, and grow old, all within one long Neptunian spring. And studying it has been just as hard as finding it. In all the years we have flown machines into space, only a single spacecraft has ever visited Neptune. That was Voyager 2, and it flew past just once, in 1989, riding a rare alignment that only lines up about once every 175 years. For a few days that August, it swept within about 5,000 kilometers of the cloud tops, and then it was gone toward interstellar space. Almost everything we knew about Neptune for the next 35 years came from that one brief afternoon. So when the James Webb Space Telescope finally turned to take a long, patient look, it was the first genuinely new view of Neptune in a generation. Webb's story with Neptune actually began a couple of years before the auroras. In 2022, when the telescope first turned toward the planet, it sent back the sharpest image of Neptune's faint rings in more than 30 years. It was the first time we had ever seen those rings glowing in infrared light, crisp and clear, the best look since Voyager raced past in 1989. For a world this dim and this far away, that alone was a quiet triumph. But the bigger prize was something Webb went hunting for next. A glow that no telescope in all of history had ever managed to capture. Auroras are one of the most beautiful things a planet can do. They happen when charged particles, usually streaming out from the Sun, get caught in a planet's magnetic field and slam down into the upper atmosphere, making the gas itself light up from within. You have seen them yourself, as the northern and southern lights. We had already confirmed them on Jupiter, on Saturn, and on Uranus, going back more than 30 years. Neptune was the lone holdout, the one missing piece of the whole set. When Voyager 2 raced past in 1989, it picked up only faint hints that auroras might be there, but it could never actually confirm them. And for decades after that, astronomers tried and failed and tried again. The glow was simply too faint and the planet too far for any instrument to catch. Then Webb aimed its near-infrared instruments at the planet, and in data gathered in 2023 and revealed to the world in 2025, it finally saw them. Bright patches of auroral light captured on Neptune for the very first time. Webb even detected the exact chemical fingerprint these auroras leave behind, a special molecule that forms only when the gas is energized, the very same signature we read on the other giant planets. After more than 30 years of trying, the last giant planet had finally given up its lights. That by itself would have made headlines around the world. But the moment scientists looked at where those lights were sitting, the story turned much stranger. On Earth, the auroras ring the poles. The northern lights are called the northern lights for a reason, because they crown the very top and bottom of the planet. The same is true on Jupiter and on Saturn. The glow gathers at the poles, because that is where a normal magnetic field funnels all those incoming particles. Neptune does not play by that rule. Webb found its auroras glowing across the planet's middle latitudes, far from the poles, roughly where South America would sit if you mapped it onto the Earth. So why are Neptune's lights stranded in completely the wrong place? The answer is one of the strangest things about this planet, and Voyager first spotted the clue back in 1989. Neptune's magnetic field is wildly, almost absurdly tilted. On most planets, the magnetic field lines up roughly with the spin, the way Earth's magnetic north sits close to its true north. Neptune's magnetic field is tipped about 47 degrees away from the axis it spins on, and worse, it is shoved off to one side, not even centered inside the planet at all. That lopsided field reaches down into the atmosphere far from the spin poles. And because auroras appear wherever the magnetic field touches the air, Neptunes end up stranded in the mid-latitudes, nowhere near the top or bottom of the world. This is the real reason the glow stayed hidden for so long. For decades, we were partly looking in the wrong place, expecting Neptune's lights to behave like everyone else's. But the tilted field was only half of the reason the glow was so hard to find. The other half was hiding in the planet's own temperature, and it is the biggest surprise of them all. When Webb studied the auroras, it also did something no one had managed since Voyager. It measured the temperature of Neptune's upper atmosphere, and the reading stopped scientists in their tracks. Since 1989, the very top of Neptune's atmosphere had cooled dramatically. The lead researcher said he was astonished because the temperature had fallen by hundreds of degrees, down to roughly half of what Voyager had measured. In a little over 3 decades, part of an entire planet had quietly lost half of its heat. Sit with that for a second, because it is genuinely hard to fit in your head. Not a storm, not a season, but the temperature of a planet's upper atmosphere dropping by half in a single human lifetime. And that one fact explains the whole mystery of the missing lights. Colder gas glows more faintly. As Neptune's upper atmosphere cooled, its auroras dimmed, fading lower and lower until they slipped beneath what our older telescopes could ever hope to detect. The lights were always there, we simply lost the ability to see them as the planet grew colder, until an instrument as sensitive as Webb finally came along. So the picture we inherited from Voyager, the one we had trusted for 35 years, was already out of date. Neptune is not a fixed, frozen photograph hanging at the edge of the solar system. It is a living world that changes, sometimes faster than we would ever dare to guess. Which leads straight to the question hiding underneath all of this. If Neptune sits so far from the Sun and it is losing heat, then how is it doing anything at all? Because the truth is the exact opposite of what its distance would suggest. This is one of the most violent, most active worlds in the entire solar system. And here is the thing. Once Webb showed us that Neptune wasn't the still, frozen world we'd assumed, scientists started looking again at everything else we thought we understood about this planet, and almost none of it held up. So here is where Neptune stops making sense, and I want you to keep one question in your mind as we go. How can the coldest, most sunlight-starved planet we know also be the most violent? Here is what should be true about Neptune. It sits in the cold and the dark, starved of sunlight, so it ought to be still and quiet and effectively dead. When Voyager looked at Uranus, that is almost exactly what it found. A pale, smooth, nearly featureless world with very little happening on it at all. Everyone expected Neptune, sitting even farther out, to be calmer still. Instead, it is the complete opposite. Neptune has the fastest winds ever measured anywhere in the solar system. They scream through its atmosphere at around 2,000 kilometers an hour. To put that into scale, the strongest wind ever recorded here on Earth reached about 400 kilometers an hour. Neptune's winds are several times faster than the worst storm our planet has ever produced. When Voyager flew past, it saw an enormous dark storm rolling through those clouds, a single spinning vortex wide enough to swallow the entire Earth. They named it the Great Dark Spot. It churned counterclockwise, much like the Great Red Spot on Jupiter, and then, years later, it simply vanished, replaced by new storms that appear and fade. So we have a planet that barely feels the sun, and yet it whips up the most ferocious weather in the entire solar system, and that takes energy. Wind, at its core, is just air moving from hot toward cold, and the greater the difference, the harder it blows. So if Neptune's winds are the strongest anywhere, then somewhere there has to be a powerful source of heat driving them. And we already know that it is not the sun. To find that heat, we have to leave the surface behind and go down deep inside the planet. The first clue is that Neptune gives off more heat than it receives from the sun. It carries its own internal warmth, leaking slowly up from somewhere deep inside. That hidden warmth is the real engine behind the winds and the storms, and it is the great difference between Neptune and its quieter twin, Uranus, which gives off almost no extra heat at all. That difference is a mystery all on its own. One leading idea is that, long ago, Uranus suffered a colossal collision, the same blow that knocked it over onto its side, and that the impact may have drained away much of its internal heat. Neptune, spared that fate, kept its inner furnace burning, and it is that surviving heat we are really watching whenever we see its storms rage. So what is actually down there? Beneath the cloud tops of hydrogen, helium, and methane lies a deep, hot, slushy mantle of water, ammonia, and methane ices. And at the very center sits a core of rock and metal, roughly the size of the Earth. The deeper you go, the more crushing the pressure becomes, climbing to millions of times the pressure at the surface of our own world. And under that kind of pressure, something almost unbelievable is thought to happen. Neptune is full of methane, and methane is rich in carbon. Squeeze carbon hard enough, and it crystallizes into the hardest, most familiar gem we know. Deep inside Neptune, scientists believe the methane is being crushed into solid diamonds. And then those diamonds fall. Picture it for a moment. Diamonds drifting down like glittering hail, sinking slowly through thousands of kilometers of hot, dark slush toward a core the size of a planet, in what researchers quite literally call diamond rain. This is not a fairy tale invented to sound dramatic. The idea was first proposed back in 1981, and in 2017 scientists recreated the conditions in a laboratory and watched diamonds form in an instant, exactly as the theory had predicted. It is still a model built on the little we can measure from so far away, so it remains a leading explanation rather than a settled fact. But it paints a breathtaking picture of this world. A planet where the weather is powered from within, and where far beneath the screaming storms, it is quietly raining diamonds in the dark. Now remember those rings that Webb photographed back in 2022? They are nothing like the bright, broad, dazzling bands of Saturn. Neptune's rings are dark, dusty, and so faint they are almost impossible to pick out against the black of space. There are 5 main ones, each named after a scientist tied to the planet's discovery: Gall, Leverrier, Lassell, Arago, and Adams. But the outermost ring, Adams, hides something that genuinely should not be possible. Instead of being a smooth, even band of material wrapped all the way around the planet, it is lumpy. Its particles are bunched into a handful of bright clumps called arcs that astronomers named after the ideals of the French Revolution: liberty, equality, and fraternity. And here is why that is a problem. Material in a ring orbits at slightly different speeds depending on its distance from the planet, so any clump should stretch out and smear into a smooth, uniform ring within just a few years. Yet these arcs have held their shape for decades. Something is penning them in, holding them together, refusing to let them spread. The leading explanation is a small nearby moon called Galatea, whose gravity may act like a shepherd, herding the particles and keeping the clumps from drifting apart. But later studies suggest that Galatea alone cannot fully explain it. And so decades after we first found them, we still do not entirely know what holds Neptune's arcs together. It is one more thing about this planet that simply refuses to behave. Neptune's rings are not its only oddity out here in the dark. The planet has at least 14 known moons, and many of them carry the scars of a violent past. One of the larger ones, Proteus, was so battered by ancient impacts that it never even managed to pull itself into a round shape. And in 2013, the Hubble telescope found a tiny moon, later named Hippocamp, that appears to be a chip knocked off Proteus by one of those very collisions. A moon born from another moon's wound. But the strangest of them all is Triton, and almost everything about it is backwards. Triton orbits Neptune in the wrong direction, moving against the planet's own spin. It is the only large moon in the entire solar system that does this. Moons that form alongside their planet all circle the same way the planet turns. So a moon going the wrong way is a moon that did not start out there. And that single clue cracks Triton's story wide open. Triton was not born as Neptune's moon at all. It is almost certainly a captured world. A dwarf planet from the Kuiper Belt, the icy ring of frozen objects out past Neptune, where Pluto also lives. In fact, Triton is a little larger than Pluto, and its density is nearly identical to Pluto's, which strongly suggests the two were born in the very same distant region. The leading idea is that Triton was once part of a pair, two icy worlds orbiting each other, until they wandered too close to Neptune. Neptune's gravity tore the partners apart, flinging one of them away into the dark and capturing the other forever. Triton was the one that got caught, and for a captured, frozen world, it is shockingly alive. Voyager saw geysers erupting from its surface, plumes of nitrogen gas shooting kilometers up into the sky. Its surface is smooth and young, constantly being resurfaced from within, and beneath the crust there may even be a hidden ocean of liquid water. It is one of the coldest places we know of anywhere, and yet it absolutely refuses to sit still. And here is the part that should genuinely stay with you. Triton's surface is stained with reddish patches, the mark of organic chemistry, the same kind of carbon-based compounds that, here on Earth, are the raw ingredients of life. Combine that with a possible ocean beneath the ice, kept liquid by the moon's own internal heat, and Triton quietly joins a very short list of worlds where the basic conditions for life might exist, on a stolen world in the dark, at the very edge of everything we can reach. But Triton's backwards orbit comes with a price. Because it moves the wrong way, Neptune's gravity is slowly dragging it inward, tightening the spiral by a tiny amount over enormous spans of time. Billions of years from now, Triton will fall close enough that Neptune's gravity will tear it apart. And when it does, the shattered debris may spread into a brilliant ring system, finally giving Neptune a halo to rival Saturn's. We will not be here to see it, but it is extraordinary to think that it is already on its way. Think about everything Webb did in just a few short sets of observations. It gave us the sharpest rings since Voyager, caught a glow we had chased for 30 years, found that glow hiding in completely the wrong part of the sky, and revealed that an entire planet had cooled by half while we simply weren't watching closely enough. In a handful of careful glances, it overturned a picture we had trusted since 1989. And that is the real lesson of Neptune. The lights were always there. The diamond rain, the screaming winds, the impossible rings, the stolen moon spiraling slowly toward its death. All of it was unfolding the entire time. 4.5 billion kilometers away, whether anyone was watching or not. We almost wrote this planet off as a frozen blue marble, a finished thing at the end of the map. And it turned out we had barely looked at all. For 35 years, we trusted a single afternoon's glance. And in that time, the planet quietly changed, cooled, and kept its secrets, and we never noticed. That is the part that should stay with you. Neptune doesn't need us to watch. It was never waiting for us, and it never will be. It simply turns in the dark at the edge of everything, doing things we are only beginning to see, indifferent to whether we are looking at all. And there are billions more worlds out there, just like it. Thanks for watching.